Welcome again, everyone. In this class, we'll study about the relation between all the triangles on same plane, where relation is defined as AB and triangle A is similar to triangle B, and that relation is an equivalence relation. So for that, first of all, we study about what is equivalence relation. Okay, for equivalence relation, we have a definition like a relation on set A. Any relation on set A can be said to be an equivalence relation if and only if the set is reflexive, symmetric, and transitive. Then only we can say the relation is equivalence relation. Okay, now moving to next, we have an example where a relation R is showing that a element of 1 1 2 2 3 3 1 2 2 1 2 3 3 2 and 1 2. It is saying that this is a reflexive, symmetric and transitive relation. So let's see how this relation is all the types of relation. Okay, first of all, here is 1 1 2 2 3 3. This show that this is a reflexive relation. Next we have a relation additional. Here is 2 1 2 3 and 3 2, that show that this is a symmetric relation. Okay, now the last one, this is saying that also this is a transitive relation because here is a all element is such that where A is related to B and B is related to C. So for all these value, there is a relation between A to C. That's why there is a transitive relation also, because this relation have all three properties. So we can say this relation is a equivalence relation. Now moving forward, what are the summarized example? With summarize, we can summarize this like we have this table: reflexivity, symmetricity and transitivity. Okay, for this here is a meaning for all individual what they are saying that, like first one is reflexivity. A is related to A means the element itself making the relation with itself. So we can say that that is a reflexive relation or reflexivity it is showing. Okay, now example is also at last given. Then symmetricity, okay, or symmetry relation. For symmetry relation, A is related to B and B is related to C, B is related to A, then only we can say that is a symmetric relation or symmetry. Okay, it is showing symmetric property of relation. Now at last one we have transitivity. Okay, in this we say that when A is related to B and B is related to C, then there must be A related to C. Then only we can say the relation is transitivity. Okay. Now next one, we have a similar triangle. First, as we are going to prove the similarity, so that's why you must know what is a similar triangle. So similar triangle, we have a different type of triangle, and those triangles are said to be similar, which have different in size, but they are must be similar in shape. Then the all triangle is said to be what? Similar triangle. Now here is a condition for similar triangle, like here is a three triangle given, and there is a condition also given, like the ratio of respective side is constant. Then only we can say the triangle are similar. Also for other also there is a ratio is constant k, then we can say they are similar triangle. Now moving to our question is that when a relation is formed between a triangle, all triangle in a single plane, then the relation is defined as AB, where triangle A is similar to triangle B, is an equivalence relation. So for that, first of all, we have this summary. We have to prove that the triangle is that relation is reflexive, symmetric and transitive, then we can say that relation is a equivalent. So consider a set T of all triangles all triangles in a plane. Okay, all triangles in a plane. So we can say that T is equal to T1, T2, T3 and Tn. There is infinite number of triangle. Now first of all, our aim is to prove the reflexibility, okay, or reflexive relation. So we can say that one triangle, if we have one triangle, we definitely say that it is similar to itself. Okay, so every triangle are similar to itself, so we can say that the relation is reflexive. Now for symmetric relation, there is, if triangle 1 is similar to triangle B, then there definitely the triangle 2 is also similar to triangle 1. So it is also satisfy the rules of symmetric relation condition. So we can say this relation is symmetric also. Now next, moving in to prove another transitive relation. Okay, so transitive relation, we have triangle T1 is similar to triangle T2. Now in same way, triangle T2 is similar to triangle T3. So we are saying that T1 is similar to T2 and T2 is similar to T3. Then there is a definitely T1 must be similar to T3. Okay, so this satisfies, this is saying that also this relation is transitive. Okay, now we can say that here is a all three relations satisfying. So we can say that this relation is saying reflexive also, symmetric also and transitive also. So the relation is equivalence relation. Okay,